Okay. All right. Tonight we're going to be talking about ratios and proportions. And I want to try to make those two concepts as clear as possible. Some of the stuff that I show you over the next couple of minutes, I'll tell you, hey, don't worry about writing that down, but here it illustrates what we're talking about. So the first concept is, what's a ratio? Okay, this thing called a ratio. You'll notice that it has two syllables in it. It has ray and then show. Those are called syllables because it's kind of like divided into two sounds, the word. And basically it's a comparison of two numbers. Okay, ratio has two syllables to it, and it's likewise it's a comparison of two numbers. And the reason I mentioned that is, as also an English teacher, I try to always think of words, tricks to remember things. So if a class had, for example, 14 girls and 20 boys, okay, so that's a ratio that can be expressed in mathematics. 14 colon, see that little colon, that's colon in English, 20. That means a ratio of 14 to 20. Okay. It also can be expressed as a fraction, and just to make it real clear here, because sometimes typing them out is not quite, that's a ratio of 14 over 20. Okay. And in this case, this is girls, because that's how it was written in the thing, is 14 girls for every 20 boys. Okay. So it's really important to just pay attention to what they say first and what they say second. And then sometimes it'll just be spelled out 14 to 20. There's a ratio of 14 to 20, 14 girls to every 20 guys. And all of them mean the same thing. And all of them are expressing a comparison of two numbers, okay? The amount of boys to girls in this case. So we call that a ratio. And we're going to look a little bit more into it here in a moment here. So you can, if you want, if this is helpful to you, you can copy down my example, but the ratio of 4 to 5, okay? So you could write it just like we did in the last slide, 4 colon 5. That is a ratio of 4 to 5. Or you can write it in the fraction form, which you will see, especially when we start comparing ratios, okay, in a moment. So 4 over 5. And that's really the same thing. This right here, 4 over 5 is really the same thing as 4 divided by 5. It's really this. Same thing, okay? And if I was reading them out loud, 4 to 5, a ratio of 4 to 5, read it as 4/5, sort of, I could say that, 4 divided by 5. Okay, so all I'm doing right now to you is familiarizing you with the concept of a ratio, what a ratio looks like, different ways we express that comparison of two numbers, okay? The next concept I want you to copy down in your notes is this word proportion, okay? Proportions. And I'd like you to go ahead and just take a moment and copy down the definition, and maybe even. All right, this idea of a proportion is, by definition, a statement that two ratios are equal, okay? Then we call them, in fact, you could even write this down, when they're equal, we actually say they are proportional, okay? So, okay, I've got that funky thing going on with my pen, so I'm gonna close out a couple of things here. We even uploaded the right portional. All right, sorry guys. Let me unplug it and plug it back in. See if that helps. Sometimes that fixes the problem. Just to plug it back in. For example, we've got the proportion in this case, 4 to 5 equals 8, the ratio 8 to 10. That's a proportion. And I want to give you a simpler example. that you probably will help in your notes. The ratio of 1 to 2 is equal to the ratio of 2 to 4, okay? We know that this is a half, and we know the second one is a half. And therefore, these two ratios are side by side, two different ratios. They're a proportion, or they're what's called proportional, okay? That's kind of how you would verbalize it. Are they proportional or are they equal? Okay. There are some other ways to talk about it too, but anyway, when you have two different ratios that are actually technically equal, then we say that they are proportional. Okay. Or another thing is sometimes they'll say they're true. Okay. You can add that to your notes, that it's a true proportion. Okay. Um, and so if we had the ratio of 4 to 5 and 8 to 10, you could write it out like this as a fraction. The ratio of 4/5 equals, okay, the ratio of 8 to 10. And right now you're probably going, hey teacher, how do I know that those are proportional, or that these two ratios are true, they're a true proportion? Here's the magic secret, which you probably want to add to your notes. Cross multiply. So if you cross multiply, which we'll get into in a minute, that is one way to tell very quickly whether or not you have a true proportion, they're proportional, okay? So in my example here, both examples, 5 times 8 is 40, 4 times 10 is 40. Okay, those are equal, they are proportional. These ratios are proportional, okay? My simpler example, 1/2 and 2/4. If I cross multiply, I get 2 times 2 is 4, 1 times 4 is 4. Hey, I got the same answer exactly. So yeah, these two ratios are a true proportional, they're proportional, okay, to each other. So that being said, yeah, and this slide is just pointing out kind of what I just mentioned. They're said to be true, okay, two proportions are said to be true. This word true you'll see with some math teachers and in some math books. If the two fractions or ratios are equivalent, which means if you cross multiply, and they're false if the fractions or ratios are not equivalent, okay? I'll give you an example of a false equivalency. If I had 1/2 and 1/3, okay? And I ask myself, okay, are these proportional? Is this a true ratio or proportion? 2 times 1 cross multiplying again is 2, 1 times 3. I get 2 and 3, I get different answers. This is a false proportion. It's not true. Okay, they're not true to be equal. If I wrote this equal sign here, that's actually not true. So it's kind of like, I'm going to put a line to that. It's not true. Okay. The proportion, the ratios 4/5 and 8/10. How would we know that? We just illustrated that on the previous slide by cross multiplying, and I got 40 in both times. So I could say this is a true proportion, okay? And we illustrated that on the last slide, okay? All right, going to move on to the next concept. This chart here, I don't think you have to fill it out with me, but you might want to fill in a couple just because you might want to go, okay, I'll kind of like this illustrate the idea of fractions as a ratio, okay? There's kind of a decimal form of that, a percent form of it, and then the actual ratio. The fraction 1/2 we know is 0.5 as a decimal, okay? 0.5 is, those are the same, okay? That's how you express that fraction or that ratio, which really is, in this case, 5/10, which again reduces down to 1/2, or it can be called 50% or a ratio of 1 to 2, okay? And this we see from one of my first slides. Yeah, okay, we're familiar with this idea that 1 to 2 is the same as 1:2, okay? Just to fill it, in some more, if I have 25%, I know that's 0.25, okay? That's 25% is 0.25. And that would be 25 over 100, which reduces down, 25 goes into 100 four times to 1/4, okay? So as a fraction, it would be 1/4, 25%. And as a ratio, I'm looking over at this 1/4 here and going, okay, that's a ratio of 1:4, 1 to 4. Okay. So that's just a couple of examples of kind of fill it in through the chart across here. What does a fraction look like as a decimal? We kind of learned that previously. It's 0.5. What does 0.5 look like as a percent? You move the decimal 2 places and it's 50. And then what would this fraction look like as a ratio? Just put the 1 first and the 2 second, okay? And then another example as well, okay? All right, again, all I'm doing is hammering you over the head with illustrating just, again, the same concept. So if you feel like you got it so far in your notes, just listen and watch along with me here. The form of 4 to 5 would be expressed in colon form of 4:5, or as a fraction form, or 4 divided by 5. 6 to 7, 6:7, 6 over 7, 6 divided by 7, et cetera, et cetera. Okay, so that's just kind of how some examples. 5 to 8 would, 5/8 would be 5:8 over here. 5, the word 2, 8, et cetera. All right, moving on. I think I'm kind of driven that to the ground a bit. Okay. Why don't you take a moment here and just copy down these, kind of spread them out on your page, because we're going to work through these in a moment together. So go ahead and take a moment and just copy these. So what we have here is, we're looking at a series of numbers, 1, 2, 3, 4, and 5 on this slide here, series of problems. And the question is, how do you figure out what the missing number is? Okay. Well, one easy way, we've got the ratio of 5 to 10 is the same as 10 to what? Okay. One easy way to do this is, I'll show you two real fast, easy ways. I always ask myself, how did this 5, see how I have the numerators in both cases? What did I multiply the 5 by to get to 10? I must have multiplied it by 2. So what if I do the same thing to the bottom side? Okay, that will give me 20. And sure enough, 5/10 is the same as a half, and so is 10/20. So that's one way to do it. I'll show you another way. Okay, if you can kind of like visualize this with me. You had 5/10 and 10 over what? You remember I said if you cross multiply, then you can get the equal answer, and that means they're equal. If I multiplied 10 times 10, I'd have 100. So I'd ask myself, what do I multiply 5 by, okay, to get to 100? I would multiply 5 times 20. 5 times 20 is 100. So that's a second way to do it real fast. And some of your brains might go, hey, I like that one better. That's just helps my brain. Walking you through number 2 here. 7/2 is the same as 14 over what? Well, 7 times 2, I know, gives me 14. So I'm going to go ahead and just do the same thing to the denominator and get a 4, okay? I've got something over 2 equals 9 over 6. I'm looking at the 2 down here. I have my two denominators given to me. I know that's multiplied by 3. So let's see here. This is going to get, let's see, a little bit interesting. So 2 times 3 equals 6. I think if I divided by, let me think about this. Yeah. So if I multiply the top by 3, I get 27. Does that seem right to me? 27 over 2. How about if I do 18? No, let's do it the other way. I'm going to do it the other way. I can see visually already. It's way easier just to figure this one out the other way, okay? And so what I'm going to do here is I'm going to go, hey, cross multiplying that times that is 18. So 9 goes into, I've got to go do 9 times 3 and get 18. That looks better. I think that's proportional. Let me think about that. No, that's not right. It's got to be times 3. There we go. It's a 3. Okay. Because 6 times 3 is 18. 2 times 9 is 18. That's going to be a 3 there. Okay. I'm just kind of talking through it with you out loud here. But that's how I would look at that. I would just cross multiply and get 18 and ask myself, okay, well, I got to make this equal 18 and I'll be proportional as well. All right. Going on to number 4 here. 4, I know that if I just multiply 4 times 2, I get 8. Well, 4 times 14, I'm just kind of thinking about this. I don't have anything to multiply by. If I do 4 times 2, gives me that. So I've got, if I cross multiply, I take my 14 and do it times 4. Okay, I'm cross multiplying these to 16, that's 56. Okay, so what I got to do is what times 8 is 56? Okay, 7 times 8 is 56, if I remember right correctly. So there's my number.
So I have just one question for you.
Absolutely.
When you've got the second set of numbers, couldn't you just divide the other number by the top number?
So I was kind of thinking that.
Okay. Yeah.
So
the 14 divided by 2 is 7.
Yes.
And then
yep.
9 divided by 3 is 3.
Yeah.
Stuff like that when it gets a little complicated like that.
Yeah, because what we did is we went 2 times 3 got me 6. So if we just divided that into this other number, in this case we're dividing, okay. And I kind of skipped over that a little bit because it was different than just multiplying something times it. But Jess, you were absolutely correct. In this case, 9 times 3 gives me 27. If I divide 3 into 12, I'd get 4. Okay, so that's a great example of how what you just said works beautifully.
It does make a little bit more sense than having to
3. So
yeah, do all work or do all that work.
12 and divide that by 3 if I write it out like this. Okay. Okay, and that's how we get a 4. Okay. All right. Next slide here. Now we're going to talk about putting these things into like very simple algebra, like one-step type algebra equations here. So I'm just going to give you a moment to copy down number 1 here, okay? Using algebra, we're going to use algebra now to solve these proportions. So you got 3/5 equals n, that's the variable over 15. And we know that we could go, okay, 5 times 3 is 15, so 3 times 3 is 9. We could have done it that way. We could have gone cross multiplying and get 45. So 5 times, 9 is 45. So it would be 9. All right. But just feeding into algebra here, okay, getting used to taking word things and putting them in the algebra. If I use my cross multiply method, I can go like this. This equals 5n, okay, that's 5 times n equals, and then 3 times 15 is 45. Okay, so I just kind of wrote that out there and give you a moment to copy that. And let's think about what I did is I did my cross multiplying. 5 times n, I know that whatever 5 times n, that will equal whatever this times this is, which in the case is 3 times 15. Okay. And then we looked at both last quarter in 60 and then also again in this class earlier, this principle of multiplication or whatever you do on one side, you're trying to get n by itself. Okay. You want to know what n equals. And since it's 5 times n, if I divide this side by 5 and divide this side by 5, okay, what that does is that cancels out my 5s, okay, and now I have n equals 5 goes into 45 9 times, okay. So algebraically, using algebra, that's kind of how we would solve these. Go ahead and take a moment and copy down number 2, and I'll walk you through that as well. So you get 5/8 equals 25 over m. M's the variable. We're trying to just solve whatever that number is that would make it an equal proportion, okay? So again, this one happens to be very similar. I've got 5m, okay, equals, and then I've got 8 times 25, which is 200. 4 times 25 is 100, so that's got to be 200 if it's 8, okay? All right. Again, I'm looking at two things. The variable is multiplied by something, so I'm going to divide to get rid of the number that's next to that variable. So I got to divide on this side as well. And I'm going to get, that cancels out my 5s. And I have now m equals. Now watch how I do this. I know that 5 goes into 100 20 times. And so I got 200, so that's twice as many, so that'd be 40. Okay, that's just how I just kind of did that math kind of quickly there in the head. The 5 goes into 240 times, okay? All right, I want you to take a moment on your own and try number 3. Just take a moment, see if you can do that on your own. Okay, so here's what I would probably do in number 3 here. I've got 2y, okay, equals, and then if I just did the math over here, 16 times 3, 18, 3 plus 1 is 4, right? 48. And then I would just get rid of the y by dividing this side by 2, which means I got to divide this side by 2. And I now get y equals 24. And times 2 would be 48, okay? So that's how I would solve that. Number 4 here, I'm not sure what happened on that one. There's something, one of those is supposed to be a variable, so we're going to skip it and move on, okay? All right, let's look at a couple of word problems, and then I think we'll be about ready to wrap it up tonight. So I'm going to look at a couple of these word problems here. Example 1, a recipe calls for 4 eggs in a cake to serve 9 people. Okay, that's my ratio. 4 eggs for every 9 people in the serving, okay? How many eggs are needed for a wedding cake for 270 people? Okay. Now you can take a moment and see if on your own you can write that out. How would you do that? If the first ratio is 4 eggs over 9 people equals, they want to know how many eggs. So you could use X for that or use A for that, any variable you want, over 270, okay? So if I wrote it out, I got a ratio of 4 per 9, okay? 4 eggs in my recipe for every 9 people. And then it says, well, how many PLE equals how many eggs are I going to need? Okay, they're wanting to know eggs. This is the eggs, okay? They're wanting to know this. And I could just say, we'll call this, I don't know, we'll call this Y, okay? Don't ask me why, okay? Over 270 people, okay? All right. So at this point, we're just going to do the exact same thing we have been doing on the previous one. We're going to cross multiply 9, say 9y equals 270 times 4, which is going to give me 8 and a 2, 8, 9, 10, 1,080. Big number, but you can use a calculator here, okay? And then I'm going to take from there and I'm just going to go, okay, I see I have 9y, there's my variable. I'm going to get rid of my variable by dividing this side by 9, do the same with this side, and then I'm going to get y equals, and you guys can figure it out from there. Just divide in your calculator 9 into 1080. Okay, so that's an example of looking at a story problem and just setting up the two ratios side by side and making them look like algebra. Okay, let's do another one. The ratio of the number of jelly beans to jawbreakers. So jelly beans is the first number. I'm really emphasizing that. Jelly beans is the first number. Jawbreakers the second number. Is 9 to 15. If there are 36 jelly beans, what is the number of jawbreakers? So I've got 9 to 15 is my first ratio, okay? 9 to 15. And this is, I'll call these JBs, okay, jelly beans. And this is, oh, that's not a good idea. They're both J. This is, just call this jelly, okay? And we'll call this jaw here, okay? These are the jawbreakers, okay? And then what is it says, if there are 36 jelly beans, okay, I'm going to keep my jelly beans together. I'll just say jelly. Then how many jawbreakers do I have? Okay, and so this is my X, okay, which stands for jawbreakers. Okay, and from there, I don't think I need to talk you through it. You know how to do it, but I just wanted to talk you through how to set it up as a ratio. I would have 9x equals 15 times 36. I would divide 9 into both sides, and I would have x equals, and I'd solve the problem. All right. Another example, the ratio of cars to trucks is 12 to 6. Okay. And I'm going to write this down here. Cars at the top, trucks bottom. Equals, if there are 248 cars, so I'm going to keep these on the same side. Okay. They want to know how many trucks are there going to be. Okay. So, and in this case, you can use whatever variable you want. You could call it T for trucks, A, B, X, Y, doesn't matter, but you would be solving for how many trucks there are, okay? Using this thing, so 12X or 12T equals whatever 6 times 248 is. All right, so I think this is about the second to last one here. Hernandez leads the baseball league with a batting average of 425. We call it 425. Okay. He struck out 2 times for every 6 times he was at bat. So he's got a ratio of 2. These are strikeouts. Okay. For every 6 at bats. All right. Equals, and then the question is asking me, if he went to bat 600 times, how many times did he strike out? So, okay, they gave me this number. They gave me 600 at bats. Okay, and again, you'll notice how I'm keeping my at bats straight across from each other. And they want to know X strikeouts, okay? And that's how you would set that up, and you're ready to rock and roll. So, so then you would have 6x equals 1200 and divide both sides by 6, and you would get 600. 600 at that. No, that doesn't sound right. Anyway, that's how you would do it. You would have 6x equals, 1200. Okay, moving on. Elise can waterproof 735 feet of decking with 3 gallons. So, and they want to know how many gallons did she need to do a 1,960 foot deck. Okay. So I'm not sure what this 2 magically appeared here for, but what I would do is I'm just thinking because I've stained many decks before, but she's got, if she uses 3 gallons, that allows her to do a 735 feet of deck. Okay. If you've painted much at all, you know, you look at your paint can, will say it covers approximately, 20 square feet or whatever. But when Elise is trying to, stain her deck and waterproof it, she knows that with 3 gallons, she can do 735. Okay. And the question is, how many gallons does it take? So they want to know the gallons. Okay. Again, to cover 1,960. Okay. 1,960 feet. It's really square feet, but of deck. And once you've set it up like that, folks, you can use whatever variable you want for gallons. You could put G, capital G or whatever, and make that your ratio. And so you would have 735 G equals whatever 3 times 1,960 is, and you'd be able to figure it out. Okay. Okay. Give you a moment. And I think this is about the last one. In the first 8 months, Kayla drove a new car 6,000 miles. Okay, so this is 8 months. She drives 6,000 miles. There's my ratio. Okay, at this rate, how many miles will her car be driven in 1 year? Okay, so that equals, okay, in 1 year, it spells out the months. That's 1 year is 12 months. Okay, if I want to I chose 12 months because I want to keep the same unit of measurement. Since they're measuring in 8 months here, I know that a year is 12 months. Okay, 12 months. How many will get me? How many? We'll call it X in this case. How many miles will be driven? And so I'm going to go do 8x equals 12 times 6,000, and I'm going to divide each side by 8, and that will tell me how many miles I will have driven, or she will have driven, Kyla, in 12 months. Okay. So again, just setting it up as a ratio or a proportion. One more. One more here, just I guess to just what do they call it? One more to go. I have an extra one to go. A snowstorm dumped 18 inches of snow in 12 hours. So 18, excuse me, inches. And it dumps this in 12 hours. Excuse me. How many inches? So they want to know X here. Okay. This is what they're trying to solve. How many inches would it do it falling per hour? Okay, so this is 12 hours, 18 and 12 hours. How many inches in 1 hour? This would be a 1, okay, in a 1 hour, okay. And then from there, I'm going to go 12x equals 18. I'm going to divide each side by 12, and that'll solve really easily and really quickly. Okay. Just to kind of summarize real fast, okay, what we've learned tonight here. I taught you kind of 2 main concepts, and ratios is a comparison of 2 numbers. By now we've kind of got that. It's expressed with colons or fractions or spelled out. And just like the word itself, it's 2 numbers. And so we looked through several examples of what ratios are. We talked about proportions, and that's basically it's 2 ratios set up side by side. Okay, if you want to, another way to look at it is that proportions are 2 ratios, 2 fractions set up side by side. And we learned that they are true or proportional. If I cross multiply and I get the same exact answer, then I know those 2 fractions are equal or equivalent. Okay, so we can say they're true or they're proportional. And we covered that. And then we went through a couple of examples of various things, again, more ratios. And then we talked about, equivalent ratios and how to solve that. And most of the time it's pretty easy. You're multiplying the same thing. And then we ran into 1 or 2 where we had to divide just because that's how we had to do to solve it. And then we started talking about, okay, what does this look like if you used algebra to solve the missing variable? And since we have an equal sign here, you see how it says equals each time? What that's telling you mathematically is whatever this is, it equals whatever this has to be. And so we know by cross multiplying, we went through 5n equals 45 and we solved for n each time. And then we went through and we did a couple of story problems, like, six or eight of these story problems, just to kind of see, okay, teacher, can you show us for story problems? Because I know I'm going to see that in my homework and maybe on the quiz. All right. Having said all of that, I'm going to